で、Apache CloudStack へのコントリビューションをするとき、気をつけないといけないところ、プロセス的な話と、あと時間があると、デモンストレーションを含めて、環境周りのことを少し説明してもらいたいと思います。
All right, last topic of the day, so hopefully we'll end a little bit early. So, homestead. Okay, quickly, before I explain how you can contribute to Apache, I want to explain to you the different roles within Apache. So, a user within Apache is someone that uses CloudStack. Okay, nothing more than that. He may eventually provide feedback to the main of this, but he's not a developer. Essentially, he is using CloudStack as a blueprint. A developer is someone who contributes something into the Apache CloudStack project, either in the form of code, or it could be documentation, or it could almost be basically very well be a contribution to the main language itself. So this is what a developer is in terms of in Apache, and sometimes it's also known as a contributor. So developer, contributor is almost synonymous with each other. So it doesn't have to be that they're writing just code. A committer within CloudStack is a special developer that actually been voted on by the Apache community, by the CloudStack community, to grant them direct access to the Git repository. So whereas a developer, if you write some code today, you have to create a patch, submit it to the Apache community, and a committer would actually take that patch and review it and commit it right into the Git repository. So there is a little bit of difference. The reason why the committer is special is because the committer is someone that the CloudStack community trusts to modify the code themselves. So typically, a committer is someone that has contributed a significant amount of patches, and these patches are what we consider as good patches. And a good patch is something that doesn't require a lot of back and forth feedback of fixing code or anything like that. So typically, when you get elevated to the committer status, it is something that the CloudStack project is trusted to modify code directly. Today, we have about the original CloudStack team prior to the Citrix acquisition. They're all committers today. There's a lot of Citrix employees that have been contributing code into CloudStack project, but they're not committer status right now. We want them to prove that they can write good code, contribute to Apache before we make them a committer as well. We also have about 5 non-Citrix employees that have already contributed enough to be voted into as a committer as part of CloudStack. And these committers range from, I believe there was one that wants to contribute UI, and she's only 2 years off college, but since joining the CloudStack project, she's written at least 30 different UI fixes. So the Apache community, CloudStack community, loved the fact that her Apache was good, made her a committer. We also have, contributors from companies like SunGuard that know the project really well and have already started contributing patches to it. And they have, and you should see a lot more of these committers being voted in. The last thing I want to talk about, one more thing about committer, and that's not on here, is a concept of what we call a maintainer. So a maintainer is one extra step special from a committer. A committer is someone that commits right to the code, right? A maintainer is someone that's been designated by the community to be responsible for a specific section within CloudStack. It could be a feature, it could be a service, it could be a plugin. Whatever it is, they are specialized in that. And so typically, a maintainer for a particular feature, let's say, would be the one responsible for reviewing any patches that are specific to his specialty, and they will review it and commit it as part of their role as a maintainer. And right now, I believe there's a list somewhere in Wiki that describes all the maintainer and all the features they're responsible for. So if you ever want to write a patch, you should probably look up the list of who you believe that patch is very closest to, and you would send an email through the mailing list and say, please can you help me review and commit this patch. The last thing is the PMC member. That really stands for Project Management Committee member. This is a really small group of people that help direct, kind of manage the project itself. They don't really go in they're not there to suggest direction of what CloudStack does, but they help manage it. So they're the ones that actually help load in the committers or decide features around the project, but they don't say CloudStack must do this and do that. That's not their job. So currently the PMC member is myself, Kevin Kluge, who is the VP of products for Citrix. He's actually my boss. And then 4 other PMC members are mentors of CloudStack, and these are they're basically people that have been with Apache for many years, and they want to be part of the Apache CloudStack project to help mentor us as we move forward through the incubation stage. Okay, so I'm going to sit down for us because I want to show you some more stuff. But quickly, the development environment today, just really quick in order to set up your development. Basically what you need is, first you need Apache Tomcat, of course, since we use the Tomcat server for development. You need some MySQL version. We say 5.58 is something you should download. You should get the latest Git, get the latest Java, get the latest version. That's really what you need to be able to start writing code within CloudStack. Quick thing here, the rest of this slide is just going to be links. I know you guys have a copy of the slides, so I'm sure you can get the links later. If you want to set up Windows environment, go to this link. If you want to set up a Mac OS environment, there's another link for that. If you're a Linux user, how many of you actually have a laptop that's based on some type of Linux? I think nobody, right? Oh, you have one? See, you're smart. You probably don't need this stuff. So if you really need how to set up Linux, I could probably find it for you. But generally, most people have written their development under either a Windows environment or a Mac OS. So quickly, what I'm going to do is show you how a Windows environment can be set up. So here's what I'm going to quickly go through instructions and then show you what I have in my own environment. I haven't written code for a very long time, so I set this up pretty fast myself. But again, what we use typically for our Java development is Eclipse. Hopefully most of you guys have heard of that. We use that as our IDE. What you want to do for Windows specifically is, of course, download Tomcat. We expect you to install some type of Cwin client. If you guys don't know what that is, it basically is a shell for Windows, so you can do Linux commands there. But one of the reasons why we really we need that is because we use something like a makeFS ISO tool that comes with Cwin that will generate ISOs for CloudStack, and the ISOs is what we use to patch system VMs within CloudStack. I'm not going to go through the rest of it. Again, you're going to have to set up MySQL, you're going to set up your paths for your Java, and then at the very end, it's going to go through some commands that go to the project. So I'm going to show you a little bit what that is. So from a development environment, I want to quickly show you that I actually included the entire project here, and I have put it all within this folder called CloudStack. So earlier this morning, I actually went ahead and got the latest from the Git master repository, and I created, I got the latest code from the master branch. I took Eclipse, and what I did was I just basically went to the import section. I clicked on the existing projects, and I browsed right to my CloudStack directory right here. And I clicked OK, and it basically will automatically to suck up every single CloudStack file in its folder for you. The way we have, if you ever looked at the CloudStack code and the jar file that we create, they're really almost a mirror to the different folders that we have already pre-generated that's here. So the agent folder contains all the agent code. Let's see, console processing contains core and additional F5 level. So you can see from here that the jars that are created later on reflect what is actually here. Since I already did that, I can actually show you how to. So when you get the first source code, what you want to do is build this, right? So the commands that we have, and this is in my slide as well, we use ant to build a CloudStack. Clean all is a target that cleans up everything. It will delete all the folders that are created during the build process and clean everything in the Tomcat server. So this cleans everything. The build all target, the build all target goes and compiles every single folder that you saw in Eclipse. It builds it up. So it's a shortcut for building everything. If you look at the XML, there are probably specific targets for each of the folders that's up there. So if you want to compile specific jar files, you can do that as well. But I'm going to build them all because it's lazy. And then what the deploy server does is it will create the WAR files from this, which is WAR file really typically in the Java world, it includes both the UI components and the lib files that it needs. And it will extract that and put it into the Tomcat server to deploy this. And then lastly, deploy DB really will clean up whatever's in the MySQL database and refresh the thing from start. So if I execute this command as is, and assuming this works, it will go in there and clean everything that I have right now, rebuild everything, put it right into the Tomcat server, and then also refresh the entire MySQL database. So I'll let it run. It's probably as it is. So as you see, it's going on. It's making the compile API, compile core, compile agent. It's actually going in there and compiling each individual one. And each of these things you see, the compile server are its own target with an N. So again, you don't have to do that. Build all. You can compile specific ones. One of the things that we did as part of the build process, and hopefully this is reflected in master, because I got this from Apache one, is the fact that it should no longer include non-Apache compatible jar files. So for example, VMware probably has a non-compatible Apache license to it. So I'm not even sure this would even compile VMware. I'm not 100% positive, but this is what the Apache CloudStack is supposed to do, whether it's done now or later. Okay, so now I've actually, I'm still compiling files. It takes a while. It's a lot of projects. I shouldn't take more than a minute. That's an SSD for that. Okay, so now it's going to, now it's the database. Okay, so quickly up here, deploy server, what that does is, you can see that it's copying files, and what it's doing is it's copying from the distribution directory. So when they do build all, it essentially creates a dist folder and puts all the compiled classes into that. When I call the deploy server, it will actually copy these files to the Tomcat web app directory for us. And then finally, when I did deploy DB, it actually goes and refreshes my entire database. So if I say add debug, which puts the Tomcat debug mode, hopefully we should start this thing. So I have not touched any of this stuff. This is basically master assets. This localhost port 880 such plan is the default port. I can tell this is a brand new instance because of this page that shows up. So what CloudStack here does here today is, if it's your first installation, you can either skip everything, or you can go with what we call a basic installation, which will quickly go through a single host installation where you can install the hypervisor and shared storage, whatever, all the configuration in a single host. So if you've never done the CloudStack installation, I would recommend you continue with the basic installation. And it'll go through a whole bunch of sections. Let me try that. So the whole goal of this is that it's going to attempt to educate you, the things that I talked about today, adding the zone, etc. But of course, the hard part about this is knowing what to fill in for each of the commands. Okay, so that kind of shows you a little bit how to, once you get the source file, looking at in the source tree. The other thing I want to show you is how we get the Git repository. So what I've done here is I created a folder, actually I created a folder for CloudStack. But if you wanted to get the very latest from Git repository, this is the command you would execute. Again, this is probably in my slides already, so I'm not copying this down. But essentially, it's cloning everything from the master Git repository from this repository down to your local laptop. And once you have executed this command, this incubator project basically comes up. So this is the exact folder you get after executing the command. And typically what you want to do, since there's only one is you probably want to give the master branch up to you. I'm already on master. And then what you want to do from here on out is what I can do when you see this work is that's good enough. So I have a file called, and I'm just going to create a flow this message. So let's just say that you modify this particular account command. What I do here is, after my testing, etc., I should probably do a git build all, just to make sure it compiles. Oops. And this will basically compile. It should go much faster now since I've already built the previous stuff. So this should technically compile what I just changed. And what I could do here. Perhaps I should have just compiled my specific build all this. So this has compiled. Assuming you've done all your testing, whatever, what you want to do is probably commit this to your local branch to do something, and then so what I'll do is I'll just create some. I'm going to create a patch for this commit. Actually put this patch. This is all policies right now, but the result of this thing is a patch file, and this is the patch file you're going to submit to the mailing list. And then I'll go through how that exactly works. But this patch file is what you want to submit to the mailing list, so that someone can take this patch file and commit it directly to the master branch for you. So I'm going to skip this part. So the very most important thing about contributing, if anybody wants to contribute, you must do this. And you must join the CloudStack Developer list, which is this one right here. So at the very least, to subscribe to it, you just email this mailing list if you belong to it. This is where you will get all technical help from various, all the project community member. But most importantly, this is where you want to ask for a review of any patches you want to submit. There's two types of early patches that you can contribute. One is a bug fix, and the other one's a really big feature. Typically, a bug fix, when you ask for someone to merge it, you would create that patch that I just said and submit it. Create two possibilities: you can create a Jira ticket or submit it to a review board. I'll have that slide later. Once you do that, if it's a small bug, what will happen is the maintainer or committer will review that, and assuming everything's okay, it will submit that patch on your behalf. If it's a big feature, what will probably likely happen is it will create a topic branch for you. Because if it's a feature, it's probably going to be a lot of patches that's going to be committed or submitted at once. So what they will probably do is create a topic branch, also mask or whatever main branch that you want to put this into, and then merge all the patches into that topic branch. When everybody's agreed it is ready to be merged back in, then you would ask the community, can we merge this back into the master branch? And one of the committer will probably do that for you. The way we do commit today in Apache is we call it lazy commit, which means that anytime, if you're a committer and you push something into the CloudStack repo, it's generally going to be okay unless someone says, no, you shouldn't do it. And the only reason why someone would decline a committer from committing something, it can only be a technical reason. It should not be for a business reason. So you can never say you cannot commit this patch because there's a business reason why you should. That's not. If you say because this is bad code or something wrong with it, technical wise, you can ask to reject this patch. But generally, all committers, once they committed it, unless someone complains about it in the next 48 hours, it's going to be directly committed to the repo itself. Other thing, some new features. So with a bug fix, generally okay. You don't really have, unless it's a really big bug. But generally, the way that Apache work on CloudStack or any of the Apache project works today is if you have a big feature, generally it's a good idea to talk about the feature. This and this. The way that Apache doesn't really like people kind of like a small group trying to decide what the feature, all of this, and then all of a sudden commit the whole thing right into the main branch. They typically would want some type of functional spec that's written and a discussion of how this feature could be improved. Now, it's probably okay for you guys to kind of think about what should be done, but I wouldn't, I wouldn't decide what the feature is, right? 1,000 lines of code, and then submit it as a patch. Right before that, I would probably want to talk about it, write a functional spec, and submit it into the mailing list, and ask for opinions, and then start writing the code after that, and incrementally improve the patch into submit patches to the mailing list. And this is every single Citrix employee today does exactly that. Some of these commands I kind of already went through. Just some high-level thing. Remember that if you're going to submit any patches into CloudStack, make sure it's properly unit tested yourself. And as part of actually changing going forward, Citrix actually created what we call it's a small team that is dedicated to a couple of things. Making sure that the CloudStack architecture is easy for our partners and vendors to contribute, and help with the release cycle management of Apache CloudStack, because we're the ones that actually know a lot about how CloudStack should be released. And then, of course, help build the automation testing framework so that it's easier for you guys to run some type of test for every single patch that you want to see, instead of manually testing it. And so there's been a team that's created within CloudStack that's dedicated specifically to doing that. If any of you ever talked to Alex or Trey who are original family engineer just like myself, they are part of that team. there's two ways to attach. You can either create a Jira ticket and attach it, or find the Jira ticket that was the bug, attach the patch right to it. And then what you would do is go to the mailing list and say, please someone review this for me and commit it on my behalf. Or you can create an account on review board. The review board is something that Apache has created. You can do the same thing through there, submit the patch, create a patch from there, go to the mailing list, say, can someone review this and submit this for me. We may think about doing something else in the future, but this is what we have currently. I've talked about the mailing list for review, but I think the biggest thing is if you do submit a lot of good patches, and what I mean by good patches is, hardly ever gets rejected. Since you've done proper unit testing, you've already gone through the mailing list, you've discussed this, then you can actually be potentially voted in to be a full-time committer. And that would be a process that's typically done by myself, Kevin, or any of the 4 mentors that we have in the PMC. Okay, so the rest of this stuff I'm going to quickly go over. I wanted to leave you guys with some of these docs and locations where you can find additional CloudStack information. For example, all the docs knowledge is either in docs.cloudstack.org or wikis.cloudstack.org. For architecture reviews, I use specific links on where you can find them. How you want to package your dependency, you can have a link of that as well. Exception handling, how we do that with CloudStack, another good information. How do we deal with database upgrades? This is actually pretty important because upgrade is very difficult. If you've ever written for OpenStack itself, probably can't even upgrade, but it's very important for CloudStack. We want to make sure we can upgrade from one version to another, especially if you're going to commit a feature that touches the database. That's the most important thing. So please, if you're ever going to create a feature, a develop feature, read this guide. And then, of course, how Git works with all the coding standards from the CloudStack. I would say the coding standards is probably your typical Java coding standard. The very last thing I'm going to leave you with, and this should actually be done, but unfortunately I didn't have a chance to try this out myself. But we created a new tool called DevCloud. And what it really does is, all the things that I've been talking to, setting up the management server, I don't even have a hypervisor to connect to. So how can you really even test some of the more inner workings? I would ask you, if this was a Linux box, I would probably run a KVM or something like that. But what DevCloud does is it's almost like an all-in-one VM, where it has all the management server, hypervisor, everything all in one. It's all set up for you, so that you don't have to go through all the pain that I just went through to set up my environment. So I gave you a link. This link actually gives you a lot more details of what DevCloud is. But it's really to help you guys get up and running to writing code, not have to worry about setting up, adding hypervisor, whatever. This should already come included with all that. So that's all I have actually for today. Any questions for what I've talked about? Not for me, but any questions to Shane that you want to ask? I know he kind of finished his feature architecture work. If you have a question on that, Shane will be happy to answer that for you as well. Oh, okay, that's great.
じゃあお願いします。午前中の話で、ストレージの、件で Hadoop との取り組みの話がありました。 で、僕がクラウドスタックはストレージ周りがちょっと弱いっていうところで、今後のところを非常に気にはしてたんですけれども、現状、スイフトとの連携、それから今日の話のバグとの連携ということで、カバーがあってできるのかなと思ってたんですけども、もともと期待していたのは、クラウドスタック自身で、ストレージに関係するところの実装をするのかなということを期待していたのですが、今後そういったところまで、クラウドスタックは、開発の領域を広げるという予定はありますでしょうか。
So I think it's very important to have an object store solution for Amazon style cloud. So I think we all agree with that. But the difference between object store and compute is unlike compute, where there are not a lot of good solutions, and not actually a single good solution. OpenStack, it just doesn't work well. This doesn't work well. So, but the storage situation is very different. There are many good solutions out there. There are numerous open source storage solutions, and there are numerous proprietary storage solutions. Like Cloudian here, pretty popular in Japan. There's a solution also very popular in Korea. Because this storage problem is not new, people have been building systems used to store photos, videos, emails for more than 10 years. So I think that's why it makes more sense for CloudStack to leverage these storage solutions out there, as opposed to try to create yet another solution on its own. That's my belief. But if some community member believe that there's a gap, then certainly they would propose it to the Apache community, and I'm sure the community would welcome such contribution. But for now, I think there seems to be very little interest in creating a storage solution just for CloudStack. Even if you look at the OpenStack storage solution, OpenStack solutions like Swift, actually, despite being relatively mature, is actually not widely adopted. There's been very few use of Swift outside of the backspace at all. So I think that there are too many solutions like Swift already out there. We're particularly excited about Hadoop because the main reason we're excited about Hadoop is because it's not just a good storage solution, but it also offers big data map reuse capabilities beyond basic object store. So I think I think that sets a different bar for different standard for object store. So we're very excited about that.
ありがとうございます。
ハドっていうのはですね、私も聞きたかったんですけれども、どういうふうな形でハドっていうのをとして、例えばAmazon の EMR みたいな形で、これはストレージというのをオブジェクトストレージに変えて、S3 に変えてやってるんですけども、そういうふうなことをやるんではなくて、HDFS を乗っけてやろうとされてるのか、それともこのオブジェクトストレージスイートを使うので、スイートのオブジェクトストレージとしてを使ってハドゥープを動かそうとしているか、それともまた違った形でクラウ クラウドスタックの方で何かやってるかっていうのはちょっとよく見えなかったんですけど、そこをどう考えられてますか？
Yeah, so how is CloudStack going to be integrated with Hadoop? There are two ways. One obvious way is to create a template to run Hadoop on CloudStack, and that has nothing to do with storage. That is just run Hadoop as a workload, and that's not what we're talking about here. That's not what we're talking about. So that's already possible. What we're talking about is to set up Hadoop independent of CloudStack on a set of physical machines. So you have HDFS running on some servers, and then you have CloudStack installed on some other servers. So the CloudStack system is like EC2. The Hadoop system is like S3. So they're two completely separate systems, but they work together. So if the templates and images will be distributed out of Hadoop, the snapshots, backup, that will be stored into Hadoop. So that's what I mean. It is really a standard installation of HDFS, not as a workload that runs on top of CloudStack.
よくわかんないですけど、それはHadoopのストレージとして使うという分野でわからないんですけど、MapReduceは全く使わないっていうことなんですか？
Yeah, good question. So Hadoop is tied with MapReduce. We don't need MapReduce at all just to use Hadoop as storage. But the important thing to remember, that you brought it up, since you brought it up, that's where we believe it's so, Hadoop is so unique and so powerful being a storage solution, because it is a type of storage that's very intelligent, and that would enable you to process data in place. So if you think of a storage solution like Swift, you have many computers, and each of these computers would have many disks. And during the normal operation of the system, the disks will be spinning, will be running, but the CPUs will be largely idle because there's not much computation required to store data. And the nice thing about Hadoop is Hadoop can then use the CPU cycle to perform useful tasks. So instead of the S3 or Swift way, where you would have to read the data out of object store, then read it into EC2 compute side, and then process it on EC2, then write the data back to S3. So imagine if we have storage built on Hadoop, then we can potentially create a service where the data processing is done by MapReduce directly on the object store. So that could be a direction. That could be a unique capability of the CloudStack Hadoop combination that we can develop in the future. But for now, for the very first step, even though we're not using Hadoop to its fullest extent, it is already a very good object store system.
今の話だと、単純に単純にデータをストアするんじゃなくて、インテリジェンスになんかいろんなことを考えてストアする、そういうふうなシステムとしてHadoopを考えていきたいというふうに私は聞こえたんですが、それいかがでよろしいですか？
Yes.
わかりました。でもう一つあるんですけど、今回ちょっと後半のAPI のところでちょっと結構ユーザーインターフェースのお話が多かったんですけども、興味があるのはこれをシンさんの見た方がいいと思うんですが、プラグインが結構いろいろできるという話で、そ そこ要はクラウドスタックの要は上側の見た目だけじゃなくて、いろんな機能、例えばスケジューリングの機能とか持ったり出すっていうと、ネットワーク部分のこととか、いろんなことができます、デプロイメントができますとか、そういうの魅力的だなとは思ったんですけど、そのことが今、アベラブで、実際 API でいろいろ使えるようになっているんでしょうか。
So you want to, I think the question is, can the plugins introduce new API?
Yeah, so I can answer this question. So in the future, actually even right now, when you create a plugin, you can also expose your own CloudStack API. I actually didn't go through how you do it, but it's very simple. You extend a existing base command, and then drop it as a jar file, and then configure command that properties to include the API. In the future, with the UI plugin framework, when the plugin framework is ready, you can also add another UI layer to make specific calls to the custom API. So for example, if you were to add a brand new physical device into, let's say Cisco, because we didn't have Cisco here. Let's say I add a Cisco firewall into CloudStack today. You could, number one, you could leverage the existing firewall commands that we have. Maybe you want to expose additional Cisco features through your own API. You can certainly do that. Also, you may want to expose configuration API, right? So that's going to take care of it. When we get to the plugin framework, you're going to be able to easily add UI components. And as I said earlier, the UI plugin framework, I don't want people contributing UI to modify CloudStack UI code. I want them to declare where have a way for people to configure the UI, declare, here are my files external to it, and then drop it in and just call your API. So today, right now, if you were to modify, if you want to leverage new API, you have to touch CloudStack UI code. With the plugin framework, you won't have to. The idea of the plugin framework is you do not have to touch CloudStack UI code. Does that make sense?
クラウドスタックの UI API を使うプラグインのフレームワークは、自分がプラグインのコードを書いて中に入れたいという時には、それを使わなきゃいけないような気がするんですけど、そういうことは大丈夫ですか。
You can write your own custom API. Yeah, you can write your own API. Is that your question?
すみません。自分の API を書くんじゃなくて、プラグインとして自分がコードを書くときに、そのプラグインのコードはそのフレームワークに従わなきゃいけないので、フレームワークの中の、要は鈴木さんのフレームワークのやり方に従って書かなきゃいけないし、何かしらのフレームワークの中のコードの中では、そのプラグイン用の中の API を入れなきゃいけないと思うんですけど、そんな形じゃないんですか。今日、例題が出てなかったので、プラグインできますって言われて、分からなかったんですけど、どういう形でプラグインを作ればいいのかな。
Okay, so let me see if I can look at the code.
Yeah, because it would be good to look at the real plugin. Look at this. What is the symbol of the plugin?
Well, the symbol is authenticator, so I guess this is the very simplest. Okay, so one of the plugins you can do is an authentication, change the way we authenticate users logging into the CloudStack environment. So by default, we have MP5 user authenticator. The logic is very, very, very simple. It's It's going to get the username, password, some additional information. It's going to try to get the account and then buy this information, and then the password equal to that, it's going to pass. Now, let's say you want to change that, right? So what you can do is create your own test user authenticator, extend this guy, right? Change implement the authenticate method, anything you want. So I can even go to this class itself. So if we go here, this is really an abstract class which implements the user authenticator interface. So it has a default implementation configured, but really all you have to do is this guy. The only thing you have to implement here is the authenticate method. So let's say you implement the authenticate method. You can add this, drop it to the jar file, and then there's a file here.
Okay,
Does that understand? Okay. Okay. Any other questions?
マネジメントサーバーのクラスター化をされるような話があったかと思うんですけど、拡大する、クラウドごとの拡大すると、確かに、マネジメントサーバーをクラスター化していくというのはいいことなんですけど、それをトータル的に管理するようなマスターになるようなマネジメントサーバーというのが考えられているのか、あともう一つは、その場合のそのセカンダリーストレージがどのようなところに置かれるのかというのをちょっと教えていただきたいです。セカンダリーストレージ。
Okay. So first, let me talk about the management server. So today we have a management server cluster per region, and most clouds have only one region. So that means you have one management server cluster per cloud, and that cluster has to sit in one availability zone. And that's why we need, today we ask people to set up a backup, a standby management server in another zone. And then the failover would be a manual process if the zone containing the active management server cluster fails, then the admin would manually bring up the management server in another zone. So what I explained earlier was going forward, we will have a separate management server cluster for each zone. So that way, failure of an entire zone will not impact the management capabilities of another zone. Now, even today, remember, even if the management server fails, the VMs are not impacted. But because the management server failed, so you cannot create any new VMs. You cannot kill the old VMs. But the VMs you already have running will continue to run. In the future, when we have a separate management server cluster per zone, then even if the entire zone goes out, none of the other zones will be impacted. So that's where we're going. And I think I also explained the storage change. Today we have what's called a secondary storage system per zone. And the secondary storage has to be an NFS server. And that's a big problem because NFS servers don't scale very well. And if a zone has, say, 10,000 servers, it will be very difficult for all these servers to visit the same NFS server. So what's happening in the future is we're eliminating secondary storage altogether. They will not be secondary storage servers. You still have primary storage, which is required to store virtual machine disks, which is required to store virtual machine disks that are running But what's stored in the secondary storage today will be in the future will be stored in object stores, in systems like Hadoop, like Swift. That's where what's in the secondary storage today will go in the future.
ビリングやメータリングについて何か教えてください。課金と、経由のメータリング、重量課金の仕組みもあったら教えてください。
So what CloudStack does today is we don't connect to any specific billing engine or engine. What we do is we will take all the events together and generate what we call a usage record. A usage record could be, for example, a running VM for 12 hours or a storage disk that had for 30 days. These are what we call a usage record. Right, we do metering, that's you're right. But in terms of billing, right, or even reporting of that data, typically we rely on something. For example, Citrix has a product called Portal, which can take this data and construct they have their own billing engine that they can take this data and create the invoice and bill the individual account. So CloudStack does not deal with any billing. We do give back to usage record. It's up to someone else to integrate their billing engine. I know there's already a couple of systems, like for example Zora. There's one, and I think there's one from France. I can't remember the name. There's also one other group that I know that has written a billing engine. But I'm sure there's other. I think there's something. That's something you can go to the CloudStack Developer or user list and ask, and I'm sure one of those guys will say what kind of support it would be out there. Other questions?
I have a question about the vulnerability on the compute host side, which I asked in a break. And so right now, the management side is has a pretty pluggable architecture, but on the other hand, the thing that happens in the compute host doesn't seem to be pluggable. I think we do SDN, and we want to have the ability to do plug a virtual machine into the virtual network before actually launching VM. So is there any I'd like to ask your thoughts on that.
Yeah, I'm not exactly sure, how to accomplish that. But I know partners like Mozilla and Midokura, they were able to plug in their SDN into CloudStack. I think in most cases the plugin we're talking about from CloudStack point of view is not really a host plugin. It's not really something that happens on the host itself. It's what we would consider a network, some type of a network level plugin. I don't know exactly what it's called, and I'm actually quite certain there should be a way to do that. There should be a way to compare the network interface or additional network interfaces before the virtual machine starts. So But I'm not exactly sure of the details. But I think Will or I will hook you up with yeah. So if there are gaps, I would recommend that if there are shortcomings of CloudStack, I would recommend that you just raise it in the mailing list. That's probably the best path forward. Sorry, I don't understand the technical details enough to answer that question.
Thanks. I have another question regarding the layer 2 basic networking with the slide. For your slide, could you go to the layer 2 basic first networking slide? This virtual router terminates the public traffic and then routes and that virtual machine does network routing and to the guest machine, right?
Yes.
In that sense, so all the compute rules when you hypervisor have to have a wire that is connected to public network. Is that correct?
Yeah, either a physical wire or a VLAN. So usually it's a VLAN.
So I see, and that means so this virtual router is the virtual machine, right? So it doesn't you can't can pin the router to the codes.
I don't know if we do it today, but I know what I think it's possible to maybe in the future limit the virtual router to a subset, a small subset of the hosts. So you would only have to have a small subset of hosts connected to the public network. Is that what you mean? Yeah. So I don't think CloudStack supports this out of the box today, but I don't think that would be very difficult.
So that right now, basically assumption is all the hosts should be able to access
Public network. Yeah, that's I think out of the box. That's not how it works.
I think it's not very hard to add that. For example, we have a way to tag compute nodes and service offerings, and every single one of these virtual router you have to specify service offerings. So you can easily tag specific hosts and say for virtual router only, and every virtual router that's created that uses that service offering, we will only put it to that host.
Yeah. So you don't even need to change code.
Yeah,
it's
already made. All of them.
You talk about you talk about the Swift combined with CloudStack. There is the performance issue. If you have, I'd like to know about that more. If you have some problem issues using Swift combined with CloudStack.
Okay, so let me clarify that. It's not a performance issue. There's no performance issue running CloudStack with Swift. Swift is functioning the way it's supposed to function. my point was Hadoop would be more efficient than Swift, would have better performance than Swift, because for certain type of operations, you would not need to read that data out of Hadoop, read it into a virtual machine, process the data, and then write the result back. Hadoop is designed, Hadoop is a storage system, but it's a smart storage system that it can process data in place. So if you can use MapReduce to avoid even allocating virtual machine instances and read data into those instances. So that's why I said it could be an advantage using Hadoop in the future. But Swift is an object, and as long as it works well as an object store, it will work well with CloudStack.
Any other questions? Okay. All right. Any other to you? Or?
ではですね、質問等がないということでしたら、ちょっとですね、時間は